Okay, this is a continuation of the last video where we blinked the LEDs, and here's the code um, for blinking the LEDs. Is nothing more than just toggling the LED on and off. So we don't care about this code. We're not gonna use it right now. We're gonna use it down the line. Now what we need is we need to talk to this Bluetooth unit and have it send data to our phone so we can display it here. So let's configure the phone first. I'm using the Blue Electronics app, and we are going to set up new communications. You can see the blue LED blinking. That means there's no connection. As soon as I establish a connection, you'll see it will go solid blue. So it's HM soft, service, and characteristic. And now we have a blue LED. We have established connection. We're going to put a console so we can see the data going back and forth. And we are going to specify the width to be 400 and the height 500. So that should make it big enough to make it readable. So you see that we only have 7 lines so far, and that's just the configuration here. Whenever anything changes here, it pops up on the console. So let's configure the processor to use serial communication. The serial communication is on pin 9 and 10 going to the HM11. These two pins, so that's 1 through 8 and then 9 and 10. So let's go back to our STM32 Cube IDE. We are on our Gyrocam demo IOC file. We're going to configure these two pins, 9 and 10. Right, these are serial communication on port 2. So we go to serial communication port 2, enable it, asynchronous, and we specify the baud rate to 9600. That is the default rate for HM11, and we generate the code. All right, so we should have code for, so it gave us this new function here to that configures everything that needs to be configured. Here's the baud rate, here's the port for serial communication. So we don't care about those details, we just want to send data. So to send data, we're going to be sending data every second. We use the library again, right? UART. We're going to transmit data, and it requires a handle to the port. That's the one. It's giving us that one because that's the only one we have so far. We're going to send the data demo, and the size of it is 5 because demo is 4 characters plus the control return 1 more character, giving it a timeout of 1 second or 1000 milliseconds. And now we should be able to uh, receive data here. Oh, sorry, I didn't realize that there wasn't. So what we did is we changed this pins, or by enabling this. So we clicked on USART2, changed the mode to asynchronous, and then changed the baud rate to 96. Then we clicked on generate code. That generated the new code here, this stuff. And then we added this line. So this function takes a pointer to the serial port. We're using number 2. And then it takes a parameter with the data we want to send. And the size of that data is 5 characters, 1, 2, 3, 4. And these two are 1 character. So that's the equivalent of number 13. And we're saying that it has a maximum of 1 second to send this data. If it's not able to send it within a second, then it just returns. And then we delay for 1 second. So let's download it uh, to the unit, and then we're going to start seeing the data pop up here. Let me switch it. Alright, so there's your demo. So let's see how fast we can execute this loop if we remove this thing. But to make it visible, let's add a counter and a buffer. Okay, and on the buffer, I'm gonna add demo, and then whatever we have and counter, whatever the counter is, so counter, and we're gonna increase it by 1. Here we're gonna get the size of buffer, and here we send whatever's in buffer. So this function is gonna take whatever this is and put it in buffer, and this is gonna get replaced by whatever this number is at the time of execution, and then this function is just gonna send buffer with whatever the length is. So let's download it, and we are going to remove the delay just to see how fast we can process data, and we'll see here this start going really fast. Alright, so there's an error on this one, and what is the error? We forgot a comma. Okay, so let's do it again. Okay, now it's downloading, and you can see it's going really fast, right? So let me switch and explain it again because I'm probably not able to see it. So we created these two variables. One is an integer, it's just a counter, and then a buffer to hold the data we're going to be putting here. This is the print function. You give it a storage location, and then it's going to put whatever this is into this, and it's going to replace this with whatever the value of this variable, and then we just send it. So you can see that it's not going very fast. Even if we increase the speed of the processor, since this processor can run up to 64 megahertz. So let's change it to 64 megahertz and generate the code. And now we're gonna download it, and there should not be any change here, even though the processor is running a lot faster now, 64 megahertz versus 16. So it's going again, and you can see it's not going very fast. No, sorry, it's just okay. There it goes. So not going very fast. All right, so we're not doing anything faster. So what that means is that this one is a bottleneck. This is not allowing us to send enough data. So we could make the timeout smaller, but by doing that, let's make it 8. Um, we're running into issues because we're saying we're giving you 8 milliseconds to send this message, and if you're not able to, just return. So that creates an issue because it's going to start sending incomplete data, and you can see now how it's not finishing the entire message. It's just concatenating. Sometimes it finishes, sometimes it doesn't. So if I change it to 2 milliseconds, it will make it more obvious, right? So there it is. Actually still downloading, but that's from the previous one. Hold on. All right, so there it is. So the data is just being concatenated all the way to the right. And it's a lot of data. So this creates a problem because if we have a variable message length, we can't know how long it's going to take. So we need to have a better way of sending the data reliably, regardless of the size, and without putting a big timeout that is going to prevent us from running more code more efficiently. So this code runs really slow because of this function. In the next video, we're going to see how we can set data a lot faster using interrupts. So, um, enjoy. I'll see you in the next video.